everyone, and welcome to my science class. Today, we're going to talk about application of Newton's laws of motion. Here, we'll discuss the first condition of equilibrium. When engineers design and build structures, they apply Newton's laws of motion. Most large structures, such as buildings, skyscrapers, and bridges, should not move, tilt, or rotate under ordinary conditions. In other words, they should remain in static equilibrium. What is static equilibrium? An object is in static equilibrium state if the sum of all the forces acting on it in each direction is equivalent to 0. Equilibrium means a state of rest or balance due to the equal action of opposing forces. Just take a look at this example. So here, if you will notice, there's a man who pushes the vehicle. So there are opposing forces acting on the object. There are four forces actually. We have the normal force, or also known as the support force. We have the gravitational force. The weight of the vehicle is affected by the gravity or the gravitational force, the frictional force, and the applied force. Remember that the normal force is balanced with the gravitational force. The tires of the car are in contact with the mud, or the tires of the car are trapped in the mud, which provide one of the conditions for the occurrence of frictional force. The frictional force counteracts the force applied by the man at the back part of the vehicle. If an object at rest and is in state of equilibrium, then we would say that the object is at static equilibrium. Static meaning stationary or at rest. Here, this is the best example for static equilibrium. The car is not moving, so the effort of the man is useless. For a system to be equilibrium, the net force must be equal to 0. And for a net force to be 0, the components of the net force must also be 0, such as x and the y components. So here, if you will notice, there are arrow symbols, and these arrows represent the direction of the forces. To further understand this, let's try to give an example. So here is example number 1. A 1.550 kilogram wet rock is hanging on a wire. The wire sag due to the weight of the rock, making 15 angles on both sides. Here, we are going to find the tensions on the wire. So in order for us to solve for the tensions, we need to follow 6 steps. So first, we need to identify the given. So if you notice here, I have written the given already. I already have my given. So 1.50 kilogram is our mass, and the angle is 15 degrees. So since the mass of the object is affected by the gravity, we need to find weight. So in order for us to find weight, weight is equal to mass times the gravity. So our mass is 1.50 kilograms. And gravity is 9.8 meter per second squared, and that is standard. So 1.50 times 9.8 meter per second squared is equivalent to 14.7 newtons. Sir, why newtons? Because when we illustrate free body diagram for us to know all the known and unknown forces. So in order for us to illustrate or to show all the forces acting on the object, we need to illustrate the FBD or the free body diagram of this one. So let us, is this complete? Of course not. We need to label it. So the purpose of this, just like what I mentioned, is for us to identify the forces acting on the object. So this one is our tension 1. So remember that this side, the right side will always be the tension 1. And tension 2 will always, the left side will always be our tension 2. So, and also we have to write here the weight. Weight will be included, of course. And then, what else? I think that's it. So that's our free body diagram for this illustration. After this, we need to plot this free body diagram, plot on the Cartesian plane. In component method, we use the Cartesian plane. So this one, this is our Cartesian plane. So here, this is the x-axis and this is the y-axis. This is, always remember that x is always horizontal. For the horizontal components, and y and vertical for the y-axis. So let us now plot the FBD of our so this will be our weight, and then this is our tension 1, and this is tension 2. This diagram or this method is not complete, so we need to illustrate or include the angle. So what is our angle? 15 degrees, both sides. 15 degrees. So this is tension 1 again, this is tension 2, and then the weight of the rock and the angle, kasi it's already given. So the angle, which is 15 degrees. 15 degrees. Since we are looking for the x and y component, we need to identify all the x components and all the y components. All the horizontal components are considered x components. All the vertical components are considered y components. So again, we need to identify first all the x components. So here, this is our this is P1x. This is x because it's horizontal and it's located in the x-axis. So this is, on the other side, this is our T2x, still x, because it's x-axis. T2 because this is tension 2. Always remember, we already labeled the left side as our tension 2. And for the right side, tension 1. And then, again, just like what I mentioned, since we are going to we have to identify all the x and y components. So this will be our, this side is our T1, tension 1 side, T1y. Why T1y? Because it's vertical and it's part of y component, and this also, this side, this line represents the pole. On the other side, same goes with the other side. So this is this is y, and this is tension 2, since we labeled this side as tension 2. Pantay pa. It's not balanced, but anyway, ayan. In component method, we identified all the components, so x and y component. I repeat, this side, or the right side, is labeled as our tension 1. Left side will be our tension 2. Now, we identify all the components. For x component, this one will be our T1x. This is our T1x because it's located in the x-axis. This is x. This is still x, but it's tension 2 side. This is T1y, it's vertical, so it's a y component, and this side is T2y, tension 2y, because it's also vertical. Always remember that this side is positive. X here is positive. The x here is positive on the right side po. Left side, the x is negative. X-axis, this one is negative. This side is positive. Why? Above the origin is positive. Y here is positive. Y-axis is positive. And then y here is negative. So again, the x here is positive on the right side. On the left side, the x is negative. On the upper side, y, it's y component, so it's vertical, so it's y. Y is positive, and here, downward direction, the y-axis is negative. Or all the y components will be negative. So that is our Cartesian plane. And that shows, or that includes all the x and y components. Now, we are going to solve for the x components. So, here, we need to prove that tension 1 is equal to tension 2. Both tensions are equal. So the formula is summation. This symbol is summation. Summation of Fx is equal to tension 1x plus tension 2x plus W. So are we clear with that? We have to remember that all forces in this summation is equivalent to, is always 0. All forces is always 0. And also weight is 0. Why? Is weight part of the x component? Is weight part of the x component? Since weight is on this part, it's vertical, so it's not part of the x component. So it's not a horizontal component. Tension 1x is a horizontal component. Tension 2x is also a horizontal component. So both tensions, T1x and T2x are in horizontal component. X-axis, but weight here is a vertical component. So it's not a horizontal component. So meaning weight is 0 since weight is not an x component. So let us simplify. T1x equal to T1x plus T2x. Since this is 0, so no need for us to write it. So we simplified it. So summation fx is equal to T1x plus T2x. Let's now substitute. So what is your summation fx? Remember, I mentioned earlier that summation fx, or the sum of all forces here, is always equivalent to 0. So this will be 0. And then is equal to T1x. The sign is positive because here T1x is located here, and the sign x here is positive. So it's positive. Plus, what is T2x? What is the sign of T2x? So it is negative because x here on this side is negative. So negative T2x. Okay, next we simplify. So 0 is equal to T1x. Positive times negative is negative minus T2x. And then we need to transpose T2x here on the other side because again we need to prove that both tensions are equal. So transpose. So this will become 0. The sign of this term will change. So from negative it will become positive. T2 is equal to T2x is equal to T1x. And then simplify, this will be T2x is equal to T1x. So here we already proved that tension 2 is equal to tension 1. But remember, since T1x is adjacent to the angle, we are going to use the cosine function. I repeat, since T1x is adjacent to the angle, meaning katabi po ng angle, we are going to use the cosine function. So this will become T2 cos, what is the angle? 15 degree is equal to T1 cos 15 degree. So that is your answer here. Again, x component proves that tension 1 is equal to tension 2. Next, let us now compute for the y component. So this is the formula to be used in y component. Summation of fy is equal to t1y plus t2y plus w. So let us now, you have to remember that all the summation of force, the sum of all the forces here is also equivalent to summation of fy is equal to 0. Can you follow? Okay. So let us now substitute. So summation of fy, just like what I mentioned, is 0, is equal to, what are we going to do? So let us identify their signs muna. Substitute. So what is T1y? T1y is positive because the T1y is located here, upper side, upper part of the Cartesian plane. In first quadrant, this is first quadrant, y here is positive because it's it's on the upper side. So pag nasa baba kasi, if y is located here, the sign will be negative. Since T1y is located here, it's positive. So positive T1y plus, what is the sign of T2y? Same with T1y because T2y is located on this side and y here is also positive. So T cartesian plane and it's a vertical component, so we have to include weight, the sign of y here is negative. So this will be negative w. So 0 is equal to t1y plus t2y plus negative w. So simplify, this will become 0 is equal to t1y plus t2y. Positive times negative is negative w. So next step is we're going to transpose the weight. So we have to transpose weight here. So this will become 0 is, sorry. So this will be 0, since it's 0, will now become from negative when we transpose a term on the other side. So the sign will change. So this will be w is equal to t1y plus t2. Okay. t1y plus t2y. Okay, and then since both are like terms, we can add this. So w is equal to this will now become 2t. Okay, w is equal to 2t y. Or this can be interchanged. Pwede siyang magkapalit kasi same lang naman siya. 2ty is equal to w. So here naman, earlier we used cosine, the trigonometric function cosine, because the x component here is adjacent to the angle, meaning katabi. Now, in y component, we are going to use the trigonometric function sine, because the y component is opposite to the angle. So here, this will now become 2. So, kanina sine, cos yung ginamit magiging 2, sorry, 2 sine, what is our angle? 2 sine 15 degrees. Where's my eraser? Sorry, commercial. I'll get my eraser. So, ibaba na po natin. Burahin muna natin si tension. I'll just get the red marker. So, this will now, again, we're going to use cosine here. So, 2t. So, y will be replaced. Kanina yung x, pinalitan ng cosine. Ngayon, si y will make it sine. 2t sine, and then include the angle, which is 15 degrees, is equal to w. Ayan na po yun. Pinalitan na, we replace y with the function, which is sine 15 degrees, is equal to w. Now, since we have to, we are looking for the tension, so both sides must be divided to 2 sine 15 degrees para maiwan po si tension. So hence 2 sine 15 degrees. So cancel like terms. Cancel. So the remaining term is tension is equal to w 2 sine will not fit. So in order for us to find the tension, we'll use this formula. So tensions is equal to weight divided by 2 sine 15 degrees. So now, let us substitute. Since we are looking for the tension, what is your weight? We already identified the weight, which is 14.7 newtons. So 14.7 newtons. And what is 2 sine 15 degrees? What is 2 sine 15 degrees? So if you will use the calculator, the answer will be, when you type 2 sine 15 degrees, the answer will be 0.52. So if you will ask me, sir, how did we come up with the weight? So the weight of the weight of the rag or the wet rag is 14.7 newtons from the given. Since we computed for the weight of the rag here. And then 2 sine 15 degree. When you use your calculator, you type 2 sine 15 degree, the answer will be 0.52. No unit. And then tension is equal to 14.7 newtons divided by 0.52. So use your calculator, so the answer will be 28.27. Don't forget to write the unit, newtons. And then box your final answer. So that's it for our lesson. I know it's very long. So just a recap. So first, when we're going to solve for this one, we have to identify first the given. So we have 1.50 kilograms, which is the mass or the amount of matter in this wet rag or particular object. And then the angle, which is 15 degree, both sides. And then since this object or the mass of the object is affected by the gravity and we are looking for the weight of the object, so we need to find its weight. So in order for us to identify the weight, we have to use the formula weight is equal to mass times the gravity. So substitute. Our mass is 1.50 kilograms times 9.8 meter per second square. Sir, where did you get 9.8 meter per second squared? That's the standard unit for gravity. So it's 9.8 meter per second squared. When you multiply it, the answer will be 14.7 newtons. Why newtons? Because when you multiply kilogram to meter per second squared, the answer is kilogram meter per second squared, or also known as newtons. Newton is the unit of force. So after identifying the given, after solving for the weight, we need to illustrate the free body diagram. So this diagram shows the forces acting on the object. So here we illustrated the free body diagram on this one. So we label this side or the right side as tension 1 and the left side as tension 2. And also weight, we included the weight because of course the weight of the wet rag must be included in our free body diagram since it hangs here on the wire. And then after identifying the free body diagram, you have to plot it on our Cartesian plane. So here is our Cartesian plane. We identify all the vertical. This one is the y-axis, and the vertical side or the vertical component. This is the x component or the horizontal component. So what is the use of component method? So we need to identify all the x and y components. So that's why we labeled this one, again we labeled this side as tension again, we identified all the x components. This side is x, t1x, because this is tension 1 again on this side, and this is x because it's horizontal. This is tension 2 because this side is labeled as tension 2, and this is T2x because it's part of the x-axis, or T2x. And that's it. That's an x component. Now, we also identified all the y components. So we draw lines here. Since this is y component, it's vertical. This is tension 1, T1y is vertical, and this is tension 2, T2y, also vertical. Remember that all x on this side is positive, on the left side, negative. This portion, or this part, the y is positive, or y-axis is positive, and this side, the y-axis is negative. And then after identifying all the x and y components, we will now solve for the x and y component and for the tension. So in x component, this is the formula. So summation fx is equal to t1x plus t2x plus w. Always remember that all forces here is equivalent to 0. So that's why summation fx is equal to 0. So this is 0. W here is 0. Why? Because w is not part of the x component. So it's part of the y component. So that's why that's why weight is 0. And then simplify. Summation fx is equal to t1x plus t2x plus, I substitute plus 0 because weight is 0, so we write here 0. And then simplify. So of course when we add this, so summation fx is equal to t1x plus t2x. And then substitute the value. So here's summation fx is 0, y0, ayun po yung sinulat kanina. And then is equal to t1x, positive t1x because t1x is on this side and x here is positive, plus t2x. t2x becomes negative because t2x here is negative, x here is negative, and then simplify. 0 is equal to t1x minus, because positive times negative is negative, so it's minus t2x. And then since we are proving that tension 1 and tension 2 must be equal or is equal, this one will be transposed to this side. And then, so it will become now, the sign will be changed. So 0 plus t, naging positive, it becomes positive, plus t2x is equal to t1x. So, eto na po yun. Again, the x component is adjacent to the angle. So, that's why we are going to use the cosine function. So, we have to replace x as cos or cosine. And then include the degree, which is 15 degrees. So, T2 will replace x as cosine 15 degree. Same with this one is equal to T1 cosine 15 degree. And that is our x component. And for y component, summation of fy the formula is this. Summation of fy is equal to t1y plus t2y plus w. Here, we included w because w is part of the vertical components or the y components. So we have to remember then again that summation fy is equivalent to 0, meaning all forces in this one is equivalent to 0. So substitute, so 0, y0, because summation fy is 0, ayun na po yun, 0, substitute. And then, t1y plus t2y. Both tensions here are positive because t1y and ty2 are both located on the upper quadrants, quadrant 1 and 2. So, y here is positive. Kaya positive po, positive, plus negative w, y negative, y weight becomes axis is negative. So this will become negative. And then we need to transpose it. So because we have to know, or we have to get the tension. So this will be transposed here. So W will now become, W is equal to T1y plus T2y. So you can add this. Like terms can be added. So T1y plus T2y. So T2ty na lang po. So we can write it as 2ty. We cancel na lang or we remove the subscript. So the W will become W, since we transpose W here, so it will now be placed here, and the W is equal to, we added this, so 2ty. It can be interchanged, so pwede siyang pagbalik na rin. So 2ty is equal to W. So kailangan we need to, tension must remain. So we divide, first is again the y component naman. Y component is opposite to the angle. So the trigonometric function that we are going to use is sine. Kaya po siya naging sine. So we substitute it as 2t. Y is sine. Kanina x is cosine. Ngayon y is sine. Include again the angle, which is 15 degree, is equal to W. Ayan lang po yun. Ginawa lang nating sine. And then, para matira, for the tension to remain, we divide both sides by 2 sine 15 degree, 2 sine 15 degree para maiwan si tension. Cancel like terms. And then this will now become 2t is equal to W over 2 sine 15 degree. That is our y component. So this one will be used as formula in order for us to find the tension. So our tension is equal to W over 2 sine 15 degrees. So substitute, we get the weight from the given, so 14.7, and then 0.52. When you type 2 sine 15 degree in your calculator,